Great to see you again in this new video. This new video is a short one. We're looking at some big O estimates for some important functions. And one of the important functions here that we can consider is the big O for polynomials. And we know polynomials are very popular in discrete mathematics, and we use them in algorithms. So deriving an expression for big O of a polynomial is in fact important. Now, we can prove that when we look at a polynomial, which is given of anx to the n plus an minus 1 times x to the power n minus 1 up to a1x plus a0, and when we have the coefficients an up to a0, that these are real numbers, then we can prove that f of x is big O of x to the n power. Now, we're not going to prove this here because I think it's rather, let's say, self-explaining, that the fact that all those other terms, those lower order terms, when x is increasing, automatically will be lower than x to the power n. They will be, they can be neglected related to x to the power n. Like we did in the previous functions, basically in the previous video, we used a second and a third power polynomial to find big O of that function. Now, when we look at other functions, we look at some graph here where we have a number of popular functions. Now, we have to be careful with the graph here because we have a y-axis which is a logarithmic scale. And what we find here, we find the n log n log n to the square, n to the third, 2 to the power n, and n factorial. These are, in fact, the different views that we can have. And of course, because of the large numbers that we have, it was very good to have the y-axis in a logarithmic scale. Now, we can find out how these different elements work in specific examples. And what we're going to try to do is to look into the algorithms and try to find the big O. Now, there are a lot of algorithms for which we already have determined big O estimates, and we can see that these elements are very interesting to know. Now, big O is n. Now, that means that we have a linear evolution with n. N increases. Logarithm of n and logarithm of n, we see that we have different elements that we can evaluate and that we can verify and see how is the function evolving and what is the most interesting position that we have. Of course, we try to have a big O as low as possible. So n log n is a big O we find a lot. N log n, these are the ones that are the most interesting. Of course, we can find n to the square, n to the third power, and 2 to the power n in certain cases. And when we find the algorithms, we try to find better algorithms which have a lower time complexity. Here you have the overview of those different time complexities, so you have an idea how these things work. This was the end for this very short video. We looked at the time complexity, we looked at the polynomial complexity, we looked at other complexities. So basically we've seen different cases for big O, and now we can continue in the next session where we look at the growth of combinations of functions. Now we're going to combine functions and see how the growth is impacted by that, or how we can deduct the growth when we have those different functions. You're doing a great job. I'm looking forward to seeing you in the next video. Thank you and bye-bye.